Hey, good morning, everyone. How did your homework go? Any questions? Okay. Any other questions? All right. 41 is, hello, did you get the chance to look at my... All right. Okay. All right. So we're going to go through them basically by one by one. Okay. We're going to look on them one by one. So I will start with 43 because it's slightly different than the other, and then I will move back to 26 and 41. I did the same one yesterday. So if I have time, I will do it. But I think I'm going to start with those which are a little bit different than the other ones. So number 43. Okay. I will read the question very carefully. Okay. A 5 feet tall woman walks at 8 feet per second toward a street light that is 20 feet above the ground. Yeah. What is the rate of change of the length of her shadow when she is 15 feet from the street light? I read the problem again because those problems should be read several times to be understood, basically. So a 5 feet tall woman, so this is, okay, that's my woman. She's 5 feet tall, so that's 5 feet. Sorry, okay. And she is walking toward the street light. So she's walking toward the street light. So there is a street light here. And the street light is 20 feet above ground. So that's my street light right here. Okay, so that's the street light. And this woman is walking toward it. Okay. So she is 5 feet and moving this way. Very good. Now, what's the rate of change? It means how fast is the length of her shadow when she's 15 feet from the street light. So this woman is walking, and that is her shadow. What is the shadow? So the shadow is, so if we take this line right there, her shadow is right there. This is the shadow. Okay. So what is really going on in this picture? First, we understand a little bit what's happening, and then we solve the problem. So this woman is moving, and she is moving, so her distance is changing, and she's moving at a rate of, a constant rate of, let's see how much, 8 feet per second. So she's moving at 8 feet per second. As she moves, this is her shadow is changing. And the question is, how fast is her shadow changing? So this is the shadow. Suppose she moved a little bit. The woman is here. Let us say at some point, this is her shadow, which is standing. So that's the shadow, which is absolutely changing with time. So this is right there. This is right there. And that's the woman. Okay. She moves a little bit. So she's 5 feet. She moves again. That's she move, that's the shadow. So the shadow is absolutely decreasing in length. As time moves by, the length of the shadow is decreasing. So that's the shadow, that's this, that's that. So it's decreasing in length. We know how fast the woman is moving. So every second, this woman moves by 8 feet. Every second, she moves by 8 feet. So how fast is the shadow decreasing? When the woman is 15 feet from the street light. We worry about that at the end. So this is, the distance is changing. The length of the shadow is changing. How fast is the length changing? So that's really the picture. So that's the length of the shadow. Okay. So my first step is really to read the problem several times to see how things are changing. Okay, now we're gonna draw one picture. So at time t, and then we introduce my variable. So at time t, at a fixed moment in time, what is the picture? The picture is this. This is the woman. So that's at some time, and this is the shadow. This is the lamp. From here to here, we have our 20 feet. And from here to here, we have our 5 feet. Okay, so that's really the picture at time t. Now we go through verbatim every aspect of the problem, every step of the problem, I mean. And we start introducing what are the variable in this problem? What is given in this problem? What's the unknown? And then the hard part, usually the equation that relates the variable. All right? Now, question number 1. What are the variables? What is changing? And I definitely start needing your input. What's changing in this problem? Okay, either you write on the chat or you in mute and tell me. The length of the shadow, very good. So we're gonna give it a name. So I'm gonna call L the length of the shadow. So I introduce here, let L of t represent the length of the shadow. And that's the rate I'm interested in, length of the shadow. What else is changing? The length of the shadow is changing with what? What's changing for the shadow to change? There is something else moving in this picture. What else is moving or changing with time? Back to you.
The position of the woman.
Exactly. Repeat what you said. I don't want to say exactly without. Repeat what you said.
The distance of the woman.
The what?
The distance of the woman.
Exactly. The distance from here to here. This woman is moving. So her distance is changing. As her distance changes, the length of her shadow changes. So we need to introduce another variable. So L is from here to here. And then we're going to introduce another, we call the 0. We're going to call X. We can call it anything we want. Let X of t be the distance from the woman to the lamppost. Okay, so these are the two things which are actually changing for us. Of course, the length of the lamp is not changing. The height of the woman is just not changing. What matters is the length of the shadow is changing and where the distance of the woman is changing to the lamp. Now, what's given to us? It means which rate it's given to us. What do we know? The speed of which one we know. So they're telling us that very clearly. They tell us that a 5 feet tall woman walks at 8 feet per second toward a street light. So the 8 feet per second represent what in my scenario? The rate of, I mean, basically the speed of what? The speed of whom? So the woman, it's the speed of the woman. Every second, the woman moves by 8 feet. Every second. So X, if you're sketching X as a function of time, okay, that's when what we know that X is decreasing. Every minute, X is moving by 8 feet. So every minute, X is moving by 8 feet. So the X dt and what is the unknown in this problem? What is the unknown? What is it we have to look for? Let's have what we look for. Let's add the question. The rate of the shadow is decreasing. It means we have to look for the LDT when X is 15 feet. Okay, so it means when the woman is 15 feet away from the lamp, at this moment in time, we don't know exactly the time, but we know where the woman is at this time. Okay, how fast is the shadow decreasing? Very good. All right, equation that relate the variable. That's the hard part in this problem. So I have two things which are changing. I have X and I have L. Previously, the relationship was very, very clear, the equation. So now how can I find an equation that's going to relate X and L? That's the hard part in this problem. That's why I want to do this problem today. What's the equation that relate those variables? How can I find something that relates them? And we're going to use the picture, the geometry of the picture. And we're going to use the idea of a similar triangle. Okay, so some of those problems will use the idea of similar triangle to be able to be done. Okay, because we don't really have a formula here to work with, but we're going to do it geometrically, the relationship. So we're going to use the idea of a similar triangle. And because it's the first time we do this, I will tell you which triangle are similar. This little triangle here, and it is similar to this big one, the red one. Okay, so we're going to use the fact that those two triangles are similar to be able to find an equation that relate the X and the L. Okay, so those problems, some of them we have formulas, and sometimes you have to be a bit creative to do them. All right, I want you to spend like 2 minutes to figure out what am I talking about? What's this idea of similarity that I am talking about? I told you which triangle I want them to be similar, the little one here and the big one. So I want to call this, let us say A, O, B. Let's give them name. And I tell this one C and D. So my triangle AOB and CDB are similar. I want you to use this similarity try to remember geometry to build an equation that relate L and X. I give you 2 minutes to do that, and then we discuss it. Please, every one of you, set up the similarity clearly in front of you. Remember similar triangle. Try to remember what does it mean. Anybody found any relationship? Okay, I can see one. Okay. All right, just keep writing, and then I will put it on the board so you guys know your mistake a little bit for those who have one. Anybody else came up with anything? Okay. All right. Very okay. I'm having good answers. All right, so let us see. AOB, this triangle is similar to this little one. So let's see what's the relationship. It means that this side, L, I'm trying to see what you guys wrote so I can work with you. Okay, so the student wrote this side of the big triangle divided by that. So what's this side here of the big triangle? From here to here, this is X plus L. It means the ratio of this side, X plus L, over 20 is equal to the ratio between the little side of this triangle, which is L, divided by 5. Yeah, that's how you guys wrote it. I'm trying to see how you wrote it, okay? So, or you can write it this way, which is usually I would rather write it this way, which is the same thing. Or you write it X plus L. I'm still looking at you guys. X, this over L, this side over that side is the same ratio as the 20 over 5. So you can write it either way you can write it either way, either this way or that. So we have to be very careful with the side we are using. Okay, so that's really how the similarity, and that's what's going to give me the relationship between my variable. So the equation is, so as I said, that's the first time we do similar triangle. That's why I want to do this problem first. So what's the equation that relate the variable? X, whether you use this or use this, is verbatim the same. It's really not, doesn't matter. Equal L over 5. You use this one, I don't care, will give us the same thing. Okay, so that's really the relation between the variable. Now, before I move on a little bit, I kept an arrow here. And then we do, why did I keep an arrow? I'm going to ask you a question, okay? Is X increasing or decreasing? Is X increasing or decreasing? The distance from the woman to the lamp, it is decreasing. How will this affect the derivative, you think? So nobody complained, but that's okay. X is the woman started from somewhere, okay, and is heading toward the post as change 1 feet per second, 8 feet per second, 8 feet per second. So since X is decreasing, the slope has to be negative. So that's why I kept this arrow in here to make sure that we come back to the idea of a negative 8, just because X is decreasing. Very good. Now, equation that relate the variable. That's the equation. We can keep it like this and differentiate, or we can be a little bit smarter about it and simplify it, because, I mean, it's obvious that it's a simple relationship. So let's simplify it a little bit before differentiating. So this is going to be, I'm going to cross multiply. Actually, I can divide by, I mean, whatever. This is equal 20L. And you know, there is 5L, 20L. It's not really smart from us to just keep it like this. So it's going to give me 5X plus 5L is 20L. We can divide across by 5. It means X plus L. I'm dividing by 5. It's going to give me 4L. And this actually gives me a very simple relationship between them. This gives me that X is 3L. Okay, so the relationship between them is actually turned out to be much simpler than we thought. But this is crucial. I mean, that's the hard part in this whole problem. Once I find a relationship between them, we differentiate with respect to time. Okay. Let's see the equation that relate the rates, basically. So, okay, so I have x equal 3L. It means basically at every time t, the distance from the woman to the post is 3 times the shadow, the length of the shadow. That's really what we are saying. At every moment in time, the distance from the woman to the shadow, sorry, the woman to the lamp is 3 times the distance of her shadow, the length of her shadow. That's the relationship between x and L, which is a very simple relationship. Now we differentiate. We get that dx dt is 3 times dl dt. Okay, and that's the equation that relates the rate of this problem. Now that we found this, we go back to the given and the unknown, and we actually start plug and shock, whatever we need to do that. So now the last step of the problem. Okay, so we have this relationship. The woman is moving at a speed which is 3 times the rate at which the shadow is changing. So now we use the given. Use the given to find the unknown. All right. So what do I have here? I have the given that dx dt is minus 8 feet. And I need to find dl dt when x equal 15. But I mean, there is no x in the formula, which means that actually the LDT is moving at a constant rate, because it's not changing. How fast the length of the shadow is changing, it doesn't really even depend on x. It means it's changing at a constant rate in this problem. So we have the x dt minus 8 equal 3 times the L dt. It means the shadow is moving at the rate of minus 8 over 3. The length, the unit is the unit of the length, which is feet, per unit of time, which is second. And that's give me how fast is the shadow moving per second. So the shadow is changing. How fast? It's 1/3 of a feet every second. It's going down because the shadow, we need that it is decreasing. Okay. Questions? So this problem is different. I'm going to assign another one that requires the idea of similar triangle, but I want you to be exposed to it before. All right. What else? At what rate is the tip of her shadow moving? So the part B is, at what rate is the tip? Let us see, what do they mean by that? At what rate is the tip of her shadow moving? Okay, so what do they mean by this question? The tip of her shadow. So let me draw the picture again and let's make sense out of this. So this is the woman. And this is at time t. Remember that everything is changing. So here at a specific time, that's what the situation is. A little bit later, everything is changed because the woman is moving. So this is my lamppost. This is my 20. And this is my 5. And this is my x, so that's okay. They want at what rate the tip of the shadow moving. What are they talking about in this problem? What do they mean by the tip of the shadow? That's the tip of the shadow. So you can imagine that's an object. That's my reference point, that's an object. As this woman moves, this tip is moving. That's really what they mean about. And the question is, how fast is the tip moving? It means how many feet per second is this one moving? So it's not the shadow, it's not this piece they want, it's actually they want how fast this distance from 0 to this point is moving. That's the tip of the shadow. Imagine this is an object, this object is moving, and they want to know how fast this object is moving. That's really the tip of the shadow. So in other words, in this problem, when they need the tip of the shadow, they want the following. I'm going to call this y. From here to here, y. And they want to know how fast is y moving. So in this problem, x of t is always the distance from the woman to the shadow, to the post, and y of t is the distance from the tip of the shadow to the post. Okay, that's really the situation. And what they want us really to know is how fast it's changing. The tip is moving and how fast it is moving. All right. So the question is, we have the x dt hasn't changed, the given. It's 8 feet per second. And what they want us to find is unknown. In this problem is dy dt. How fast is y is changing. So this is y from here to here. It's moving. How fast it is moving. All right. So there's an easy way to do this problem and a harder way. The easy way is the following. This is L. And we know how fast L is moving. And we know how fast X is moving. So one way to do this problem is the following. We say that for every moment in time, x of t is plus L of t. Every moment in time, the distance from here to here is the distance between the post and the woman plus the length of the shadow. So we can differentiate this with respect to time, which is actually kind of neat idea, plus the LDT. And why I did that? Because from the previous problem, I know this. From the previous problem, that's the given, then I can find dy dt. So this is going to be equal to 8 minus 8, everything is decreasing, minus 8/3. And that's from the previous problem, which is going to give me minus 24 minus 32 over 3 feet per second. Okay. So that's how we can do this problem, just because we did the one before it. If we didn't have part A, then you will have to set up again similar triangle and proceed. Okay. Very good. All right, so please go over this problem carefully. What I'm giving you today on related date is actually a very simple problem, but on your exam, it will not be. It will be problems along those lines, but I want you to be prepared for it before I hit you with that on the exam. So for number 20, whatever, 21, I'll give you a hint, and I want you then to do it. So number 21, I will not, sorry, I'm at 26. I will not solve all of it, but I will give you a hint. And hopefully you guys can go from there. A hint, the problem is the following. You have a parabola, this one, and they want to, it's only the right part, that's a parabola, y equal x squared. And you have a little bit a bug, which is moving along this. Along it. So you have a bug which is moving along the parabola. So at every moment in time, the bug is on the parabola, every moment in time. And they tell you that the distance from the parabola to, from the origin here to the parabola, from the origin to the bug, this is the distance L, is changing. Of course it's changing. The bug is moving. This is changing. This is changing. Is changing. Okay, now as it's changed, so as the bug moves, the x-coordinate is also changing. The x-coordinate is also changing. So every time this bug moves, the distance changed, the x-coordinate changed, the y-coordinate changed, and the x-coordinate changed with time. So everything is really changing with time. Now they tell me, okay, the distance, let me call it L, is changing at a certain rate. So they're giving me the rate. How fast is this one changing? So every second, how fast, how much is this changing? So they're giving me this. And they're asking me, at this time, X change. So how fast is X is changing? And we know to do that, we need to find a relationship between L and X. Okay, so what's the relationship between L and X? That's really the idea. Okay, is it hard to find the relationship between L and X? I give you a minute and then I'll have to start the quiz. So I need a relationship. Who can give me any idea? Let's draw the picture usually and figure it out. Anybody can find anything. We're gonna start the quiz because. Anyone? Okay, think about it then. Think about it. This is L, this is X, this is Y. There is a natural relationship between them. Pythagorean, to the rescue. Absolutely. Very good. But I have the L dt. I want the X dt. But there is this Y staring at me. Can I get rid of this Y? What's the relationship now between X? Remember, the point is on the parabola. The point is on the parabola. The point is on the parabola. So this Y is actually what in terms of X? The point is on the parabola. So this Y is what? It's not just any Y. The point is not moving freely. The X and Y are connected to each other. So what is my Y? X squared. Okay, that's the relationship, and you guys go from there. All right, so that's my hint for number 26. For those who didn't do it, that's really the hint. And on Monday, I'm going to assign, I think, one more problem or two at most along those lines. And then we move on to chapter 4. All right, please get started with your quiz.